Okay, for the second example, this is actually a previous exam question. So for this case, instead of like a first order differential equation, I purposely pick a second order differential equation. So just to make the standard higher now. So we have two second order differential equations, d square x over dt square plus 2x equal y. So that is the first equation. And the second one, d square y over dt square plus 2y equal x. Right, so now it's going to be the same as before. We have been given two initial conditions, x not equal 4, y not equal 2, and x prime 0 and y prime 0 are both equal 0 in the second order differential equation. And of course, you need two initial conditions to substitute. Alright, so for the case of this, so this question is guided. It's a previous exam question, as I mentioned to you just now. So the question asks you to show that ys is going to be given by this function, right? And then after you have got that ys is going to be given by this function, you're going to determine xt and yt. Like you know what, like the funny thing is that when we give questions, this kind of question in the final exam, like we have a reason to do so. The reason is that even if you don't get the same answer for ys, like we were hopeful that you will be using this ys in order to find xt and yt, right? So meaning that we're guiding you. Like even if you get something else for ys, still use this and find this to find xt and yt. Even if you don't get full mark for A, you should have be able to get full mark for B. But the problem is that, like, I don't know where does the confidence come from. Instead of using whatever ys that we have given you, so you would have used the wrong ys that you get from your calculation. So it's there for a reason. The reason is that even though you get it wrong for A, you should be able to get it right for B. So therefore, if it's given in the question, please make use of that. It's there for a reason. We don't just give it to you, you know, just for fun. Alright, so I'm going to start with my calculation. So step number 1 is I'm going to start Laplacing equation number 1. So equation number 1. So when I Laplace transform, I'll end up with Laplace of x double prime plus 2 Laplace of x. So I apply the linearity theorem. And on the other side, I'm going to have Laplace of y. Is it y? That's right. So I'm going to have Laplace of y. So now here, first I'm going to have to apply the formula for Laplace of x double prime. And according to the formula, we're given by s square capital X of s. Remember, only the first term is capital and only the first term is positive. The rest is going to be minus s x of 0 minus x prime of 0. So you can find this in the appendix. And then the middle term is going to be plus 2 capital X of s, and that is going to equal capital Y of s. Again, and after you have Laplace transform each of the terms, substitute the initial condition. From the initial condition given, so my x naught value, that is going to equal 4. Remember to multiply that by s, do not leave it be. And x prime 0, the value is going to equal 0. And whatever terms that are the same in terms of the same variable, referring to this xs and xs over here, so what you're supposed to do is you are supposed to put them together, factorize them. So therefore I'll end up with something like this. So x of s, so multiply that, this is going to be s square plus 2. And this is going to be 0, and then I'm going to have minus 4s, and on the other side is going to equal capital Y of s. Okay, so that will be for equation number 1. I'm going to do the same for equation number 2 as well. All I have to do is Laplace transform both sides of the equation. So for equation number 2, I'm going to Laplace of y double prime. It's going to be y, the second derivative, and plus 2 Laplace of y, and that is going to equal the Laplace of x. Again, the formula for this is going to be s squared capital Y of s minus s y naught minus y prime of 0. And then I'm going to have plus 2 Laplace y is capital Y of s, and on this side I'm going to have capital X of s. Same idea. So to substitute the initial condition, y naught for this case is going to equal 2. Y prime 0 is going to equal 0. And whatever terms that are related, for this case is going to be ys and ys. So we are going to factorize and put them together. So I'll end up with ys multiplied by s squared plus 2 and minus 2s. That is going to equal capital X of s. And this is going to be my equation number 3. I'm going to call this as equation number 4. Okay, now remember, for this case, instead of using substitution, if you have a look at complexity of both of this, so both of them are equally complex. But you can actually substitute 4 into 3, but you have to be very careful with that as well. Okay, so instead of doing substitution, I'm going to use elimination instead. But if you refer back to the example, to the guided question, it says over here for A, we have to show ys. If you have to show ys, so meaning that what variable you have to eliminate, you have to get rid of x. Okay, so you can only get y if you eliminate the x. So that's what we're going to do. So we are going to start eliminating x. Okay, however, for this case, like for the previous one substitution, the arrangement doesn't matter. So it could be either way. But for the case of when you use elimination, so in terms of the arrangement, put the variable together, the non-variable on the right hand side. So I'll share it to you later. Okay, so now I want you to notice one thing in terms of the coefficient. Remember when we discussed this before? So at the beginning, so when I use elimination method, so the coefficient of the variable must be equal. So this is where we're going to apply that. So if I wanted to get rid of x, I have to make sure that the coefficient of x is equal. Okay, for this case, for equation number 3, the coefficient of x is given by s squared plus 2. But for equation number 4, the coefficient of x is given by a constant of 1. So therefore, in order to make them the same, what I have to do is, so equation number 4, the whole term is to be multiplied by s squared plus 2. Remember, you don't only multiply this term by s squared plus 2, but every single term is going to be multiplied by s squared plus 2. Now let's see what happens when I do that. So I'm going to simply copy equation number 3. So then put over here. So this is equation number 3. So it's given by xs multiplied by s squared plus 2. So I'm going to rearrange. So variables is going to be on the left hand side and non-variable is going to be on the right hand side. So that's how it become like this. So this is from equation number 3. So let's use a red pen for this. Okay, and then remember equation number 4, I am supposed to multiply each of the term by s squared plus 2. So now what happens is that the equation is going to change. So I'm going to have ys is going to be multiplied by s squared plus 2 and another s squared plus 2. So that will be s squared plus 2 square. And then the middle term is going to be 2s. Sorry, I'm not going to put the middle term right here. I'm going to move this to the other side. And here I'm going to have xs minus xs multiplied by s squared plus 2. And when I bring this to the other side, it's going to be a positive of 2s multiplied by s squared plus 2. So each of the term has to be multiplied by s squared plus 2. Okay, now let's put a... Alright, so now you have to think about, like as I mentioned to you before, when you use elimination, it's like when you wanted to get rid of one variable, like it could be additional and it could be subtraction process as well. And for this case, when I wanted to get rid of the x of s, now that the coefficient is the same, this is s squared plus 2 and this is also s squared plus 2, what I'm going to do is I'm going to add them up together, because I know that when I add them up, so this is going to be xs s squared plus 2 minus xs s squared plus 2, so that is going to be 0. Now you only have to add up the equation. So I'm going to start with the left hand side. So I am going to end up with negative y of s. So I'll have negative y of s from the top plus, and then I'm going to have ys multiplied by s squared plus 2 squared at the bottom, right? So that is going to be in terms of variable. And on the right hand side, I have 4s plus 2s multiplied by s squared plus 2. So that's how my equation looks like. And notice what happens is that when I use elimination again, so I get rid of x. Get rid of one of the variable, and this is what we wanted. And if you notice as well, so I'm going to start simplifying this and find ys, and this is ys and this ys as well. So I am going to have to put them together. So when I simplify the left hand side, I'll end up with something like this. So I'm going to have ys. So when I expand this term right here, so I will somehow end up with s to the power of 4 plus 4s to the power of 2. So plus 4, and then I'm going to include this. So when I include this, so it's going to be, let me use black pen for this. It's going to be negative 1. And on this side, I'm going to have 4s plus, let me expand this, I'm going to have 2s cubed plus 4s. And now when I simplify, I'll end up with ys multiplied by, this is going to be s to the power of 4 plus 4s squared plus 3. And here I'll end up with 2s cubed plus 8s. And of course, I can simplify this. So I'm going to have 2s cubed plus 8s over this particular function. But this particular cubic function, no, it's not cubic, it's quartic function. So what happened is that this is actually reducible, and it can be factorized to s squared plus 3 multiplied by s squared plus 1. So this is I have shown according to the question. So I'm going to have to show that ys is going to be given by this function, 2s cubed plus 8s. That is what I have at the top. And at the bottom, it's just the other way around. It doesn't matter as long as you have both of this function, s squared plus 3 and also s squared plus 1. So we have reached A. So this is what A wanted. We have to show that ys is given by this function. Okay, so we actually achieved that by using elimination. All we have to do is we make the coefficient equal. So we get rid of one of the variable, we simplify and obtain what is going to be ys. I'm not sure about you, but like I always find elimination easier. But then again, find whatever that suits you. Right, so now that I already have ys, I'm going to proceed and find what is going to be yt. And I know that yt is simply going to be the Laplace inverse of the previous function, which is 2s cubed plus 8s over s squared plus 3 multiplied by s squared plus 1. Okay, so now that I already have this, now we have to think about, so what method are we going to use in order to find the Laplace inverse? And I did mention this to you before, like when you have multiple factors, so these are called multiple factors, you have multiple bracket, s squared plus 3 and s squared plus 1, automatically don't think about it further, this is definitely going to be partial fraction. More than one bracket, automatically it's going to be partial fraction, okay? But the thing is that both of these are given as a quadratic expression, so you have to check whether they are reducible or irreducible. And for this case, what happened is that both of them are irreducible. So that is bad news because the function is going to be slightly complicated. You have to leave it in this form. Okay, so now let's do partial fraction. So I know that you must be a pro at this by now. You should be. Okay, so I'm going to have 2x cubed plus 8s over s squared plus 3 multiplied by s squared plus 1. So I'm going to end up with two fractions. The first one is going to be s squared plus 3, or you could also put s squared plus 1. It doesn't matter. At the end, solution is going to be the same. And then the other one is going to be s squared plus 1. And if you remember what I actually explained to you about in the first video in partial fraction, when you have s to the power of 2 at the bottom, automatically at the top I'll end up with as plus b, and the other one is going to be cs plus d, or a plus bs is fine, plus c plus ds, whatever that you're more comfortable with, as long as you can have one s to the power of 1 and the other one is s to the power of 0. Okay, so now if I were to equate the denominator, this is just going to be cross multiply for this case, and I'll end up with something like this. So 2s cubed plus 8s, it's going to equal as plus b multiplied by s squared plus 1. And then I also have cs plus d, that is going to be multiplied by s squared plus 3. Alright, so the thing is that if you notice in my lecture on partial fraction, I always favor the substitution method. But I did mention to you also the fact that substitution only works when it is a linear factor, but now it's not linear. So this is a quadratic factor, so therefore I couldn't find value to substitute. I could have substituted s equals 0, probably it would work. No, it wouldn't work. I'll end up with the b and d. Yes, I don't want that. So therefore for cases like this, so you will end up using comparison. Okay, let me see what I'm going to do first. You can expand this if you want, but I don't want to. I can actually guess just from by looking at that. So I'm going to start with s to the power of 3. Okay, on this side I have a coefficient of 2. So this is my coefficient 2. And on this side I know that if I were to expand this and this is going to be as cubed. So I'm going to have a, and this is going to be c s cubed. So I'm going to have a plus c is going to equal 2. When you do comparison, sometimes like you're not going to be able to get the answer straight away, but you will end up with simultaneous equation, which I expect what we will get for this case. And if I were to compare for s to the power of 2, so there's none over here, so it's 0. But if I were to expand, I'll end up with, for this case, this is going to be cube s. I'm going to have both of this, so I'll have a b. And for this one, I'll have d multiplied by s squared. So I'm going to have b plus d is going to equal 0. And then for s to the power of 1, and again, like if you are like you find it confusing to actually figure it out like me, so please expand this. So just write, so it's going to be a s cubed plus b s squared and so on. I don't want to write that, so that is why, because I can figure it out. So if you can't, no need to write that, or else do it. So for s to the power of 1, coefficient is going to equal 8 on the left hand side, and I know that when I multiply a and that, I will get as. So my coefficient is going to be a, and here I'll end up with 3c, because cs multiplied by 3, that is going to equal 3c. And for constant s to the power of 0, I'll have a 0 on this side, and then I'll have a b plus 3d. So that will be the outcome. Alright, so from this two, so I can actually figure out what is going to be the value of AC, B and D. I'll be able to figure out the value of A and C from this. So if I were to minus this equation, I'll get rid of A minus A. So I will be able to get that, and put a green in this. 2 minus A, that is going to equal negative 6. And I'm going to have C minus 3C, that is going to equal negative 2C. So my C value, that is going to equal 3. So that is going to be my first constant. And using the first equation, so I'll get that A is going to equal 2 minus 3. So my A value is going to equal negative of 1. That is going to be my value of A and C. And then I have this equation over here, and I'm going to minus as well. So I'm referring to this too. So from here, I'll be able to figure out B and D. When I do the comparison, I'll have 0 minus 0, that is going to be a 0. B minus B, that is a 0. D minus 3D, that is going to equal negative 2D. So meaning by D is going to equal 0. And if I were to substitute here, I'll be able to figure out that B is also going to equal 0. Okay, so now I can substitute into my equation. So I wanted to get the YT. So my yt is going to equal the Laplace inverse of A, so which is going to be given by negative 1. So I'm going to have negative 1s plus b, which is 0. So it's going to be negative s over s squared plus 3 plus, so my c value is going to equal 3 and my d value is going to equal 0. So I'm going to have 3s over s squared plus 1. So that is how my equation somehow looks like. It's a very simple one. So therefore here, when I Laplace inverse, so this is simply by using the table, and have a look right here, this is s to the power of 2, and I have s at the top. Right away we can tell that this is going to be a cosine function. And the first one is going to be converted to negative cos of square root 3t. Remember what you have over here, this is a square. If my a square is equal to 3, so my a value is going to equal square root of 3. And here I'm going to have plus 3. This is going to be cos of 1t. So that will be the outcome. That is going to be my y function. So it will be given by negative cos square root 3t plus 3 cos of t. Alright, so now, however, remember this is not the end of the calculation yet. We only have the first function, which is yt. And we need to find what is going to be x of t. Okay, how do we find x of t again? We're going to use one of this equation right here. We need to find x. We don't know what is x double prime. We don't know this either. This is only the information that we had. So therefore, definitely we cannot use equation number 1. And then for this one, this is what we wanted to find. So we don't know what is going to be the value. But we already have y, and we can find y prime by differentiating our function twice. So therefore, we are going to use equation number 2. So what is the equation? So x is going to equal y double prime plus 2y. Okay, let me write the equation. So x is going to equal y double prime plus 2y. So now let's figure out what is going to be y double prime. Okay, when I differentiate this for the first time, so we know that sine, cos, negative sine, negative cos, so better be safe than sorry. So clockwise is going to be for differentiation. So negative cos is going to be positive of sine, so I'm going to have square root 3, so sine of square root 3t, and cos is going to be negative sine, so I'm going to have negative 3 sine of t. So that will be my y prime. My y double prime, when I differentiate this again, sine is going to be cos, so I have square root 3 is going to be 3 cos of square root 3t, so negative sine is going to be negative cos, so I'm going to have negative 3 cos of t. So that is going to be my y double prime. So when I substitute into this equation, so I'll have that x is going to equal 3 cos of square root 3t minus 3 cos of t, and plus twice of y, which is going to be square root 3 sine of square root 3t minus 3 sine of t. So we have two type of terms right here, the one with cos and sine. So let's figure out if we can actually simplify any of them. No, this is the wrong function to substitute. So I'm not substituting my y double prime, substituting my I should be substituting my y right here. Sorry, let me write it again. So my y is given by negative cos square root 3t, this is the y, plus 3 cos of t. So don't do silly mistakes like that. So mistakes at copying. Okay, so when I simplify, so this 2 is in terms of square root of square root 3t, and this is going to be also cos of square root 3t, but I have 3 minus 2, that is going to equal 1, so therefore I'll have 1 cos of square root 3t, and here I have negative 3, and this is going to be a 6 minus 3, I'll end up with a 3 cos of t. So that is going to be my function x of t. Again, so this one is complicated not because I'm using elimination, no way. So it's more complicated than the previous because of the order. When you have like higher order, the higher the order is, the more complicated the calculation is. Okay, so the only way to get by this and get familiar with the calculation is going to be by using the exercise. So try to do a lot of exercise. You can do the exercise in the book, and you can try the final exam questions as well. So that would be very helpful.